All right, here we go. Let's take a look at the next section. This is Mr. Brust. This section, we're going to combine your two favorite things, trigonometry and solving equations. It's going to be awesome. Let's get in there and get started. Let's solve this equation over here. Notice we're going to start off by restricting the domain. So we're going to say, hey, I'm only talking about answers between 0 and 2 pi because there's so many different trig values there. So we're going to limit it for these first couple of examples. When I say exact values, that means, hey, yeah, use the unit circle. Check that out. I want the exact special case where that happens. So use the unit circle over here. When we say the approximate values, that's where we're going to type them in the calculator. I guess you could go old school and find a table that generates them, but that would be ridiculous. Just use the calculator and find these approximate values over here. All right, let's solve this bad boy here. So just like any equation, I want to get x by itself. So I'm going to start working backwards here and say, okay, let's subtract 5 from both sides. So it's just like a normal equation. Boom, those cancel out. We're looking at what? 2 sine x equals -1. Awesome. And then what are we going to do here? Yeah, just divide both sides by 2. So we're getting that trig function by itself. Boom, there it is. And now we're looking at, hey, the sine of x is going to equal -1/2. Awesome. All right, so when we're here, what do we got to do to get x by itself? We're going to take the inverse sine of sine. So to cancel out, like square cancels a square root, we're going to inverse sine the sine of x. Whatever you do one side, you got to do the other side. So we're going to come over here and take the inverse sine of what? -1/2. If you want to use arc sine, totally legit. You can use that. What's the goal here? So these cancel each other out. That was our whole goal, and we're left with plain old x. And now we got to think about, hey, what is the inverse sine of -1/2? So we got to think about our old unit circle there. Let's bring that bad boy over here. And where in the world does it equal -1/2? So the sine value is the y. We're going to look at what? It's going to be some kind of thing of pi over 6, but it's negative, so it's going to be down here. It's going to be whoosh, this bad boy here, this bad boy here. So we're talking about what? Pi over 6 after pi. So I know 6 pi over 6 is pi, so add one more. I'm at 7 pi over 6. And where else can it happen? This bad boy over here, he's not quite 12 pi over 6, which is 2 pi, so he's one less. He's 11 pi over 6. So there we go. So there are two answers in that restricted domain that are going to give us the answer there. Awesome. Excellent. Can we do the same thing with a calculator? Sure. Oh, check this bad boy out. Don't write this down. But really, if I wrote the problem like this, no worries. Let's just forget about tan. I know you love the trig functions. Let's forget about tan. Aha, this is a nice, chill factor of the trinomial. We're good to go. You know, this is a whole x plus 4, x minus 2. So just like solving equations, I'm going to erase that so I have some space. So just like doing that, we're going to do it with the trig function in there. So it all works out the same. So here we go. What are we going to do here? We're going to say, okay, it's going to be the tangent of x plus 4. And we're going to times that by the tangent of x minus 2. Because what multiplies to -8 and adds to 2? It's going to be 4 and 2. So we're just putting a little trig in there. Getting a little triggy with it. Awesome. Now, when we have it this far, what are we going to do? We kind of look at both parentheses separately. We're going to say, okay, when does the tangent of x plus 4 equal 0? That's going to make one answer. That's that little zero product rule where anything times 0 is 0. What makes this parentheses? Well, if tangent of x minus 2 equals 0. So if either one of these equals 0, 0 times anything is 0, we get an answer. So solve this. I'm just going to bring the 4 over if that's cool. I'm not going to show that step. I think we're cool in that. Subtract 4 from both sides. So we get, when does the tangent of x equal -4? Add 2 to both sides on this one. And we're going to say, when does the tangent of x equal 2? These are not on the unit circle. All right, let's put these bad boys in the calculator and see what we come up with here. So I'm looking for, when does tangent equal -4? So we're going to inverse tangent that bad boy right there. So we're going to say inverse tangent of -4. And we get this -1.325 thing. So I'm just going to bring it over so we can look at it. What does this mean? So, okay, I know the exact values aren't on the unit circle, but we still need to go back to the unit circle. I made this little handy-dandy guy here where I just kind of put the decimal equivalent. So pi is 3.14, half pi is 1.57, just so I know what I'm talking about. Because remember, the calculator is only going to give you tangent in the first or fourth quadrant. In this case, it gave us fourth quadrant because that's where tangent's negative. So it's something like this, -1.32, like that. But where else is tangent negative? Where else are the signs different? Aha, up here. So the calculator won't tell you the other version of that where tangent's negative. So you have to be careful. you actually have to find these bad boys. So let's go ahead and find these. I'm going to kind of clean up my notation here. So in the calculator, I did what? Inverse tangent. So another way to write that is we could have said arctangent. So I want you to be familiar with this. X is what? X is the arctan of -4. So you may see this notation like on a multiple choice question or something like that. So that's really what I found. And what did I get? I got -1. I'm just going to truncate again, -1.325. I'm just going to cut off at 3 decimals. Now, be careful. Is that in my restricted domain? It's not in the restricted domain. That's a huge bummer. So I got to put it in the restricted domain. So let me get rid of that. So I can't call it negative. So instead of calling this negative from here to here, -1.328, what can I do? Just add 2 pi to that bad boy. So we're just going to add 2 pi to this. So make sure we're in a good spot right here. So let's put that in the calculator because I want to have that exact decimal. So let's just add 2 pi to this and see what we come up with. And we're going to get 4.957. Excellent. So that is, now it's in the restricted domain, 4.957. Awesome. So there's one answer. Now there's more answers. So I have this -1.325. I added 2 pi to get back to here, but I also need this one over here. So what do I really need to do? I got to go back and I got to add a pi to get over here. It's on the other side, like 180 degrees away. So we got to go back to that -1.325 again. I'm going to bring up the exact value again. I'm going to kind of bring up that inverse tangent of -4. So I have it. And then another answer would be is if I just add a pi to it. So what am I finding here? I've got 1.815. So 1.815. So that's another possible answer. And what is that? That's if I go this way, 1.815. Fantastic. So 2 answers there. We got to get them both. Oh, man. Now we got to do the other side. Holy cow. So what's going on over here? So we've got the -4. Well, it could also be with tangents too. So again, just so we're cool with notation, I'm going to take the inverse tangent of both sides, or I'm going to take the arctan of both sides. And now I'm taking the arctangent of 2. So that's just what I'm showing, what I'm typing in the calculator. Now, what's the calculator going to give me? Well, I know tangent's going to be a +2. It's going to give me something in this first quadrant. So let's find that bad boy. See what we got here. Where's it at? There he is. Let's clear this out. We got a lot going on over here. So let's do inverse tangent of 2. Inverse tangent of 2. And we get up with something like this, 1.107. And that's in that first quadrant there. So 1.107. Let me write that down before I forget it. We've got 1.107. And again, roughly, it's not 1.57. It's something, I'll do this one in blue. It's maybe something like this. Just a rough estimate. Really, I'm just worried about the quadrant. So this little chunk here, 1.107. Where else is tangent positive, though? Because it's not going to give you both. Straight across. I love tangent. It's just straight across. So luckily, this one's in my restricted domain. All I got to do to add to this one is what? Just add pi to it. I just need to get to the other side. Let's try that again. Add pi to that bad boy, so we can just take that answer, add some pi to it, and we are going to get to 4.248. Let me write all that down. 4.428. Fantastic. There it is right there. Boom. So what are my answers? So I've got these that are in the restricted domain. I've got these 2 that are in restricted domain. So I've got 4 possible answers between 0 and 2 pi that all work. That is awesome. Okay, let's do it when we don't restrict the domain. Let's go ahead and knock them out if I want every possible sine value or cosine value or tan value that can do it. So can I solve this equation? Sure. Just knock it out like you're solving an equation. I want to get, in this case, theta. You can use x if you want, or theta. It stands for the same thing. I'm going to use theta just for some reps. That cancels that out. And I'm looking at cosine squared theta equals, I'm going to write that as 1/2. Ooh, that's nice because I'm looking for exact values. And again, I'm going to, how do I get rid of that square though? I actually have to square root both sides. So I'm going to square root both sides. Very interesting. Well, that's cool because cosine squared, square rooted is just cosine. Now be careful, when you introduce a square root, what happens? It becomes plus or minus the square root. Now, what are you allowed to do with square roots? You're allowed to square root the top over the square root of the bottom. And then what is the square root of 1? It's just 1. What's the square root of 2? What's the square root of 2? But got to rationalize the denominator. So we've got to go ahead and times this by radical 2, times this by radical 2. Oh, this is intense. So on top, to get rid of that denominator on bottom, it looks like I'm looking at radical 2. Square root 2 times square root 2 is 2. And don't forget that is all plus or minus. Let me just rewrite that bad boy here so we have it. So I'm looking for the cosine of theta equals the plus or minus square root of 2 over 2. So bust out your unit circle here, just draw a little rough sketch here, and I'm looking for where does cosine do this? Well, I know it's going to happen at pi over 4. That's the classic radical 2 over 2. And since I'm talking about all the plus ones for cosine, that's here, and here's where it's positive. What about for negative radical 2 over 2? That takes care of this one and this one. It's all of these. Holy cow. So there's a bunch of them. So how do I write all this out? Well, there's a couple different ways. You can just take the initial one you got. So I'm gonna write it two ways, if that's coolio to start. So the first one is, yeah, it was pi over 4. And then it could be, what? From pi over 4, it could be, what, pi later? You could say plus pi n. This is a very interesting one. Or I could have said, what was the other one I got over here for the negative? I got, what is that? 3 pi over 4? And it happens what? It happens every pi over n from there. So like adding, I always think of degrees back, pi is 180. It's just the other side of the line. So this is all possible angles. You could just list all 4 individually if you wanted to. I guess that would be kind of tedious. But you could list pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and just save 2 pi n. And again, the key to this is where n is an integer for that. Awesome. That is every possible value. We got to add that little caveat there. Okay, can we do it for approximating? Yes, we can. Let's do it right here. Sound like Bob the Builder there. Yes, we can. Be careful here. Don't write this down again. I'm big on don't write this down. This is what a lot of people like to do. They like to just divide by sign on both sides. This is not good. Don't do this. So, yes, it works. It'll give you one of the answers, but it's going to cancel out some answers. So anytime you can't really divide by that variable like that, that's going to cause problems. So what are you going to do then? Well, we're actually going to set it equal to 0. This is a factoring problem. So this is a classic one. You're definitely going to see this. So we're going to subtract sine from both sides, sine of theta. And if you truly dislike theta, you can write x. You can rewrite them. It's the same thing. But we are talking about an angle, so it's not too bad to write it like that. So we're looking at what? This is 3 sine theta minus sine theta. And what's that going to equal? There's nothing on the right side. It's going to equal 0. So now maybe you can see it. Now it's a factoring problem. What is the greatest common factor? Or what do they share? They both have a sign. So I'm going to take a sign out. And there's a sign. And what's left? Well, I've still got a 3. It was sine squared. It becomes sine. So it's 3 sine. And then I took the sign out. So this will just be minus 1. Awesome. Now we need to solve this bad boy. So I always think of it as 2 separate problems. What makes this 0 over here? So we're thinking about, hey, when does the sine of theta equal 0? Also, we got to think about this parentheses right here. When does 3 sine theta minus 1 equal 0? And then we got to find all possible values where it happens. I love it. This is intense. So let's solve this real quick. I can add 1 to both sides and divide by 3. So I'm going to kind of skip some steps there. I hope that's cool. Add the 1, you get 1, divide by 3. We're really looking for when does this sine equal 1/3. Okay, so I popped up the approximate, just a little rough circle so I can see. So I can go to my calculator and say, or I don't need it for this. When does the sine, I know it's approximate, but when does the sine equal 0? Well, I know sine equals 0 here at 0. And it also equals it over here at pi and then back here again. So I know this is going to make an answer at 0 or pi. I'm just going to say pi. And then don't forget, if it happens every single time, what am I adding back and forth? You're adding plus pi n. So I'm taking care of, that's going to take care of the quadrantals here, the ones right across this. It's going to take care of that. Awesome. How about over here? So what makes 1/3? Now I definitely need my calculator. So I'm going to go to my calculator, pop that up. It's going to, let me clear all this out. There's a lot going on here. I'm going to say, okay, what is the inverse sine of 1/3? So I know the ratio, I want that angle. And it's 0.339 if you truncate, so it's going to be 0.339. So I know that's going to say, hey, one angle for theta is 0.339. Boom, there it is. But I know because it's an inverse trig for sine, it's only going to give it to me 1 and 4. So it gave me this one right here. That's it. It didn't give me the other one. So So where else is sine positive? So if sine is positive here, sine is also positive in the second quadrant. So I'm looking for this bad boy over here. So if we're talking about this angle here is 0.339 above the x-axis here, then I need to find a guy who's just a little bit short of pi. He didn't quite make it to pi, so he's 0.339 below pi. So back to the calculator. Holy cow, here we go. So I'm going to take pi, and I'm going to subtract 0.339, or if you want to be really precise, you can take the inverse sine of that 1/3. And this will give it to me in the second quadrant, and we get 2.8017. So let's write that bad boy down. 2.8017. I won't write the 7. I'm just going to truncate it here. So here are my two possible angles here. Holy cow. But now, because it's all approximate values forever, it keeps repeating. So I have to do what to these bad boys? I have to add 2 pi to each of these because I'm going to go around the circle forever and ever and ever. And I'm going to do this right here. And I'm good to go. Don't forget theta can also equal this bad boy over here. And that takes care of all possible solutions for this. Wow. Just to double check, if you want, you can actually graph these bad boys in the calculator. So this is kind of a nice little trick for checking. If you just graph them, so I can graph y equals sine squared. Just be careful how you type sine in. So you're actually squaring the entire sine thing. So check out how I wrote that. I took sine of x, put in parentheses, squared the whole thing. So I want to know, when does sine squared x equal sine x? Sine x sounds like cold medicine or something. And then I'm going to graph these bad boys. Make sure you zoom trig so you have a nice window. And I know I'm going quick here because this is just a quick check. But the ideal is, where are these hitting? They should be hitting at every pi plus pi n. So let's just check it. So trace pi. And what does it give me? You can see they hit perfectly here. That's where they cross. And again, if I type these in, the exact values, that's all the places they cross. That's super cool. Awesome. All right, we only have 6 problems to do, and we've knocked out 4 of them. All right, let's solve this bad boy. So just like our equations, we're going to go through our steps of trying to get x by itself. So if I want to get x by itself, got to add 1 to both sides. So I'm going to add the 1 to both sides, and I'm looking at what? It's less than or equal to -2. Then I need to get rid of that 4 in front, so I'm going to divide both sides by 4. Divide both sides by 4, and we're looking at cosine x is less than or equal to, I'm going to go ahead and reduce that, -1/2. Awesome. Now notice this is less than, so what I want you to do is include a little sketch. There's some rules we can memorize, but let's just kind of almost like test values of where this answer is true. Okay, so I know I want less than, but let's just find what x is going to be here, where it's equal to part of this. So where does cosine x give you a -1? So we're going to do the inverse cosine of -1. Here's the unit circle. We've got that restricted domain again, so I'm only looking between 0 and 2 pi. Don't have to worry about that whole n thing. And do I get -1/2 for cosine? It looks like I'm going to get it right up here at this bad boy up there. So what is that, 2 pi over 3? Awesome. Is there another place that's going to happen? Yes, so I know it happens up here. Cosine's also negative in this quadrant. So if I add another pi over 3 past that, I also get 4 pi over 3. So here are my point of interest. So the question is it happening in between these two or on the other side of it? Like, are my answers in here or on the outside of this? So to do that, let's make a little rough sketch here. So let's just graph this first part right here. Let's go back to this, and I want to graph this side of the equation, like y equals 4 cosine x minus 1. So it can be rough. I just want to get an idea. So let's go 1, 2, 3, 4, 5. And I know that it's got this, its new axis right here at -1. I know it's cosine, so it's going to start above 1. Oops, I should use the same color here. I didn't realize we're going above 2. So I'm going to go 4 above for cosine. So 1, 2, 3, 4. It starts up here. I know cosine ends 2 pi later. I know in the middle it's going to be down here 1, 2, 3, 4. And I know you love graphing these. I think trig functions are awesome. I can do this all day long. There it is right there. So I've got this really rough idea. Oh, man. I hope it looks curvy enough. Okay, that side's got some nice curve to it. Very nice. Very nice. Excellent. Now let's graph the other side. So what about this one? I want to know, when is it less than or equal to -3? So 1, 2, 3. Here's where I'm concerned about. Boom. This line right here. And this is where they hit. So this is my whole y equals -3. And those are the point of intersections, which if I did it right, should these points right here. So does that look like negative 2 pi over 3 and 4 pi over 3? It sure does, man. Congratulations, you nailed it. Those are the 2 points. So I like the highlighter because I think the highlighter is awesome. I'm looking for when is the trig function less than negative 3. So I'm actually looking for I'm looking for this underneath the curve. Now you don't have to get a highlighter out, although I highly recommend it because it's really fun. And now, so where are my solution sets? They're in the highlighter region. Let's go ahead and write those bad boys out. So I know I can see the actual answers where it crosses. Now, what does that mean? My x values are squished in between what? They're everything below the curve here. So they're below 2 pi over 3. And I'm sorry, yeah, and so my x's are going to be between 2 pi over 3 and 4 pi over 3. So that is my solution set for all possible answers that make that equation true. So I like to have a little rough sketch, plug and chug, and you're good to go. Woo, that's fun. That's a big problem right there. We nailed it. All right, the finale. This is just kind of weird. This could happen a couple times, but I just want you to be prepared for it. Like, Mr. Brust never taught me that. Check out this. What I do, I mess with the inside here. So we've got this horizontal dilation, or I'm changing the period of this. But just solve it like a normal equation. Let's not worry about that yet. Let's just go through the steps of solving this. So I'm looking at cosine of 2 theta equals what? 0. Oh, that's awesome. So now let's just figure out when this happens. So what am I really doing? So I got kind of slack there. I'm not going to lie. I'm really saying, hey, when does cosine of 2 theta equal 0? But I'm actually saying I got to get rid of cosine. I'm doing the inverse cosine of cosine. Now in my answer keys, I did show them all. So you can see all those awesome steps. But this is what I'm really doing. I'm actually saying take the inverse cosine of both sides. Excellent. Now, why am I doing that? Well, what happens? Well, this cancels this. So they cancel each other out. And what's left? We're left with 2 theta. So here I really got to show the steps. Now, what is the inverse cosine of 0? Well, go to your chart and find where's cosine 0. It's going to happen up here at pi over 2. And there. So go ahead and just write it out. So I'm looking at these 2 points on the graph, and I'm doing all exact values. So I'm starting at pi over 2. If I add pi to that, I'll be at my next one, and pi n. So that'll take care of pi over 2, 3 pi, and we keep going back and forth, adding pi and pi. But am I done? No, not done. Why? Because that's 2 theta. So what do we got to do? We have to divide both sides by 2. And why do I do that? That'll actually give me theta. And now when I do this, what happens? I've got pi over 2 divided by 2. Well, that becomes pi over 4. Plus, what's pi over n divided by 2? It is pi over 2n. So it does mess up your answer, and it makes sense. You don't have to write this down, but if you think about this, if you graph that cosine up there at 4, it changes the period, so you're going to get, normally you just get one set of answers, but now because it's littler like that, if I drew in where is it hit? So if I drew where is it hitting at 4, that'd be something like this. You can see there's 1, 2, 3, 4 answers happening. There's more answers happening in that normal. That was in our normal 2 pi range. So that's why I have more answers. That's why it's going to mess things up. It's just getting more answers. Okay, you can check that if you want. If you double pi over 4, put it back in your equation, and you double it, that gets you to pi over 2. And you can see those answers. Just know that the period creates more answers, and you're good to go. That's it. That's trig equations with some trig inequalities thrown in there. Good luck on the mastery check. Peace out.